All right, so it says consider the function the natural log of x, and then we have the graph of f of x, which is the natural log of x. And then it says, and this is a better representation of logs. Remember that the natural log is a log with a base of e, Euler's number. But anyways, it says match the transformation uh, with a behavior. All right. So g of x is negative 1/2 of x, and it is going to be f of x minus 2. So now this minus 2 thing means it's going to shift over 2 units, and then it's going to flip. So this will be, and then it'll be 1/2. So this is at negative, or this is at 1, but now it'll be at negative 1/2. This is close to 2, but now it'll be negative 1. So my graph will kind of look like this, but then we're going to shift it over 2 units to the right. So that graph will kind of look like, well, 2 units to the right. So it'll come down like this. And kind of look like that. That's roughly what g of x will look like. And we could graph it if we wanted to, but so then what does that mean? That means that the function decreases as x increases. So that's the first one. So let's do that. So the next one, it says f of I of x or j of x is shifted down 1/2. So remember, this is just a vertical shift. So all these points are going to go down a 1/2 a point. So this is 0, so now it goes down to 1/2. This is whatever this is, it just gets shifted down. This is about 1, this gets shifted down. This is about 2, it gets shifted down. So this is j of x. So what does that mean? Well, it has a vertical asymptote at 0. And these are the choices, so I'm not going to show you the choices, but you just got to match them up. Now, this would not be true for our first function, g of x, because its vertical asymptote does not occur at 0. Its vertical asymptote occurs at 2, right? So this has, so the vertical asymptote means it's never going to cross this fence. So if you look at g of x, the vertical asymptote is at x equals 2. But if you look at j of x in green, it's never going to cross the y-axis, and neither is f of x, okay? Now for h of x is a different thing. H of x, we'll do that in red, is going to be shifted to the right 1/2. So it's going to be basically f of x, but this point is going to be here. This point is going to be here. This point is going to be here. So it's going to look like this. And it's very similar, but that's h of x. And so where is that going to cross at? Well, this one says it's going to cross at 1.5. Because the reason is it's shifting over 0.5 and f crosses at 1. So that one is going to have an x-intercept at 1.5. And those were really the three. Well, there's a fourth choice, but it's extraneous. We're not going to use that one. So basically, you're just going to think about those transformations, and clearly you can see, like, J of x doesn't have an x-intercept at 1.5, right? J of x does have a vertical asymptote at 0. So again, this is one of those things where Mr. Adams is not the most fond of. Like some kid in a hurry could choose the wrong one, I suppose. And G of x definitely decreases as x increases because of that negative 1/2 in front. Okay? I think the goal is for you guys to learn how to transform the functions in your head without having to graph it. I've graphed almost every example problem that we've gone through in class so that you can act to confirm what it should look like. Now, these are just rough sketches, right? Like, clearly, that's not exactly how to look on a calculator, but I can kind of guess what it would look like if I were to graph it on a calculator. And that's the end goal, is to transform the function, because basically what you have to do when you use math in the real world is you get a bunch of data, and the data might look like the blue line, the data might look like the purple line, the data might look like the red line or the green line, and then you have to figure out how do you change the equation to fit the data. And so this could be the growth of a company. This could be a reduction in cost. There's lots of real world scenarios where you just collect data. This could, an exponential growth or a logarithmic growth or decay. Could be, even like the coronavirus that has an exponential growth with regards to the number of cases. So the predictions about what we need to do, how we need to, that's all based on math. And so knowing how to transform the functions, that's how they come up with an equation, and they plug the number into the equation, and that's how they come up with the answers. Or predictions, I'm sorry. Because prediction doesn't mean that it's going to be true. You might guess that it's 300,000 people, but then it might actually be 400,000. So they readjust these equations too.